Good afternoon, everybody. My name is Charlie Nicklin. I'm the Chief Executive of IAgrE, and I'd like to thank you all for joining our lunchtime lecture today. Today, I'd like to welcome Tom Beach, who is going to talk to us about his experiences with autonomous vehicles in agriculture. And to be a little bit different, Tom will be doing his presentation from the middle of a field somewhere in Cheshire. Tom is an engineering graduate from Harper Adams. He grew up on a farm and he's had a real passion to move agriculture forwards. His interests in autonomous agriculture started during his studies, and with a trip to Agritechnica in 2019, it set him on a journey with the Danish company Agritechnica and their autonomous ROBOTTI product. So in today's lecture, Tom will be talking about the business he's established called Autonomous Agri Solutions and his experiences so far with the ROBOTTI product. Just before Tom starts, you're all currently muted. If you'd like to ask questions, please use the chat function at the bottom of the screen. And at the end of the presentation, we'll unmute you so you can ask your question in person. So with no further ado, over to you, Tom.
Thank you for that excellent introduction. Good afternoon, everyone. I'm Tom Beach from Autonomous Agri Solutions, which is a company I founded October last year with my colleague, Jack Wyatt. Jack Wyatt is unfortunately unable to join us for this lecture, so I'll be speaking on behalf of the both of us. So I'd like to start off with a little bit of background about myself and some of my experiences that have led up to the point I'm at now working with ROBOTTI. I've grown up on a fruit and vegetable farm in Warwickshire, and I've always been interested in the machinery part of it. And having small old tractors from the 1960s working in our apple orchards, it hasn't always been the best opportunity to get involved with the cutting edge of agriculture. But actually, some of the principles of engineering and the skills I learned growing up on the farm have really been useful as a foundation to build from. After that, I worked for a range of fresh produce growers before starting university, of which it took me out to Senegal in West Africa, where I learned resourcefulness and had a lot of challenges working in the middle of a desert, trying to keep a fresh produce farm's machinery up and running when it's very challenging to source parts, components, and do repairs. I also at this point didn't have a lot of experience, so I was very much learning on the go. Following that, I began studying agricultural engineering at Harper Adams University, where I was exposed to a massively wide range of not only agricultural technologies, but Harper Adams staff and other students as well, who have got a range of experiences in our sector. I'm a big sponge, and I was just taking in all of this engineering knowledge and really learning from it and just seeing where I could fit in and find my little niche. I'm not by any means the most academic student, but I couldn't have come to a better place than Harper Adams to progress my studies and move forwards. In 2019, we were given the opportunity to travel to Hanover in Germany to visit Agritechnica, an agricultural show. I was blown away by the range of machinery there. It was incredible. And I decided that I wasn't going to go as a student, I was going to go as a young professional. So I had no intentions of starting a business going to Agritechnica, but I went round there, someone that wanted to be part of the industry and part of moving it forwards. So every day I would venture around the show, looking at the different opportunities and especially looking at the new and innovative technologies. Of course, this took me straight away to robotics, and there was a wide range of robotics at Agritechnica. Looking through all of it, nearly every company said the same kind of things to me. Everyone was saying, this is our idea, this is the stage we're at with research, and in 5 years we want to be at this position, in 10 years we want to be at this position. Some people had some videos, some people had some concept machines. No one could give me a lot of tangible stuff that I could get my hands on and get stuck into. Until I approached Agritechnica's stand. When I approached Agritechnica's stand and saw ROBOTTI, which is just behind me, I was expecting them to tell me the same story I'd heard at all of the other stands about how this was a concept and how this was how they intended to develop it for the future of agriculture, not the today of agriculture. And actually, I was shocked that the first thing they said to me was, would you like to buy one? Now that was really exciting and set the alarm bells ringing in my head. And from that moment, I knew I wanted to be involved in some way, in some form, in what Agritechnica were doing. I spent about 2 hours at the stand talking to an amazing amount of knowledgeable staff who spoke excellent English and were from a farming background. They were very clever engineers that had done a lot of work and spent a lot of time in getting the machine to the point it was in 2019. But they were people who spoke my language and talked to me in a way that was relatable to me. So leaving Agritechnica, I was still thinking the whole time about Agritechnica and waiting for them to get back in touch with me, which they shortly did. And our initial idea was that we didn't know what we were going to do for them, but we knew we wanted to be involved. So Jack and myself at this point, who had been with me through this whole process, we were unable to purchase a ROBOTTI. It was not suitable for our family farms at home. Due to some of the initial investment, we're not in a position to be buying any new machinery, never mind something as cutting edge as ROBOTTI. So I reached out to my broad network of contacts I built up in the fresh produce industry and proposed the idea to Agritechnica that I would set up a introductory demonstration event that I would be able to host to allow Agritechnica to bring ROBOTTI to the UK for their first in-field demonstration, and also provide a networking opportunity for people within the fresh produce sector where I had my experience working with salad growers and different vegetable growers. That didn't quite work out as planned, unfortunately, because there was a big pandemic and coronavirus came along and ruined all of these plans for hosting events and traveling. Fortunately, in August 2020, we were able to fly out to Denmark, to a city called Aarhus, to visit Agritechnica's headquarters and discuss the potential future of us working together and how we could develop. At this point, I'd put in a lot of work into getting the word out there about ROBOTTI and spoken to a lot of farmers about what their thoughts were in principle, but I was still lacking in a lot of the knowledge required to answer their questions about ROBOTTI. Going out to Denmark, we learned the answer to all of those questions. And this was the point where we proposed that Jack and myself would set up as the UK dealership and the UK partners for Agritechnica. That was agreed, and there were a lot of challenges there, being two young students at that point, not graduates, with limited resources to have this working, but we did have a couple of things going for us. We had a drive and a passion and a real keen interest to be involved in this moving forward. Not only because we wanted to be part of the industry moving forward, but because we really believed in this product and we really could see how this was something farmers are able to utilize in the here and now, not just in the future of agriculture. So overcoming all of these challenges and being greatly supported by Agritechnica, who have taken a big leap of faith with us, but I believe their leap of faith is now paying off, we set up Autonomous Agri Solutions. Autonomous Agri Solutions currently is purely focusing on ROBOTTI. We are always discussing with Agritechnica how there are many unique situations within our UK agricultural systems that means there's never going to be one machine that will fit all farms and work for all systems. So we would like to be in a position one day where we're able to provide the same opportunity to other companies when they're ready that have developed machinery that can either complement what ROBOTTI does or perform tasks that it is currently unable to do. Of course, though, our primary focus will always be on ROBOTTI due to the support Agritechnica have provided us with. Now, moving forwards, we were still planning on having our demonstration event and having a press launch to show the first ROBOTTI in the UK. But alongside what we were doing in our setup process, a farm in Suffolk called Home Farm Nicklin were also interested in ROBOTTI and had seen it about. And they actually took a big leap of faith and decided to purchase a ROBOTTI without even having one demonstration and without going to Denmark. So that was delivered directly from factory and sold directly through the support of a buying collaborative called From Farmers, who we now work very closely with. This was not a setback for us, but it just meant we weren't going to be the first ones in the UK to have one. But what it did is give us an excellent opportunity to begin our business and have it functioning. We were there to take delivery of ROBOTTI and support Home Farm Nicklin with their training and setup. In the meantime, it gave us some brilliant hands-on experience, getting to know ROBOTTI and getting stuck in working with it. We were also able to prove to the Agri and Tele staff that we had the skills we were telling them we had, and we had the knowledge and the drive and the wherewithal to make things happen, even though from some people's point of view, the odds were stacked against us a bit. Now, Home Farm Nicklin are actually our #1 salesman. They are brilliant because they are getting on so fantastically with ROBOTTI. They're a farm based in Suffolk, near Ipswich, and they grow a range of vegetables in different systems. Primarily, they've bought a ROBOTTI to use in their bed systems for their organic crop. By no means is ROBOTTI only applicable to organic crops. This was just the here and now need for Home Farm Nicklin. I'd like to now show you a short video that shows ROBOTTI working in practice and interviews a few of the key people working at Home Farm Nicklin and to get their point of view on how they're getting on in a real world environment working with ROBOTTI.
My name is Andrew Williams and I'm Farms Director here at Home Farm Nicklin. Home Farm Nicklin is a purely tenanted business on land around the Felixstowe Peninsula. We farm about 1900 hectares, of which 10% is fully converted to organic production. On the back of this organic production, we had been thinking quite seriously for a while about investing in the technology when it was available to do some of the more repetitive tasks around weeding. So Fram Farmers made us aware that ROBOTTI had developed an autonomous tractor that was ready to do this work, and we started a conversation with the Agritechnica guys. We brought ROBOTTI in because we had been open to the idea of this technology. We were just waiting for somebody to come up with the right product, and we basically wanted to do the very repetitive and keep moving the soil again and again around our organic vegetables.
I'm Tom Howe. I work for Home Farm Nicklin, and I've been working alongside the ROBOTTI operation. Here, while I'm not doing ROBOTTI, I do a lot of irrigation and also land cultivation work. We've been using ROBOTTI mainly for comb weeding. At the moment it's set behind us on some organic onion plants, and basically we're just going through with a comb, a thin tine, to pull out all the the small weeds sort of before they get established and become more of a nuisance. So it's sort of a little and often job. We keep going over these, which is a good advantage of ROBOTTI because you can just leave it till it's due and you haven't got to worry about it. And yeah, it's very cost effective. The main task is just all weeding work mainly at the moment, just to try and reduce our manual labour cost for weeding. Just hoeing all our veg. We grow a lot of veg, so like cauliflowers, broccoli, like onion plants, leeks. Yeah, just try and use it across the board going forward, when we get more implements for it. Yeah, so far they look good. The organic onions, they look a lot cleaner than they did this time last year when we didn't have ROBOTTI. I think going forward it's only going to improve when we get more up to date with using ROBOTTI and learning more how it goes. I think it's only going to be an advantage, I think, in our front. I think we're the first ones to purchase a ROBOTTI in the UK because we had a ready-made job for it. With the organic land we've got and the tasks we had, we could see that ROBOTTI would fit in very well, and we had a ready-made job for it. I think others will be close on our heels perhaps, but we had a here and now need for a product like ROBOTTI.
bit of a dramatic promotion for us at the end, but Agritechnica have made that video to support us there and market it. So Fram farmers were mentioned there, and I'd just like to talk about them briefly, and that also explains why I'm stood in the field right now. So Fram farmers are a buying cooperative that facilitate these deals to happen for farmers and allow them to go through the process in a much smoother and easier manner. Going forwards, we will work closely with Fram farmers. So if any of their group members would like to purchase a ROBOTTI, we will be able to support them through the process, mitigating the need to go directly to Agritechnica. Fram farmers have also put on 3 demonstration events around the country, one in East Sussex, one in Cambridgeshire, and one in Cheshire. So I've been taking ROBOTTI to all of these events, and it's been a really great opportunity to get people to see ROBOTTI, touch it, see it working, get their hands on it and get stuck in to understand how it works. And just seeing that this is not something you will only see in the Farmers Weekly or on YouTube. This is something you're going to see more and more of in fields in the UK. So what is ROBOTTI? I haven't talked a lot about ROBOTTI itself. ROBOTTI is a fully autonomous tractor with a conventional 3-point hitch and 150 horsepower. ROBOTTI is something you can pre-program a designated route plan, take into the field and press start. Once you've pressed start on ROBOTTI, it's able to move up and down the field, utilising its PTO and external hydraulics, lifting up the implements, adjusting its draft height, controlling its speed, and turning around at the headlands. You're automatically on a controlled traffic system by using ROBOTTI because of its level of accuracy. And due to it weighing, without an implement, only 3.1 tons, ROBOTTI has a far lower soil compaction than using conventional tractors. There's a paper being published imminently by Agritechnica, where they work with a lot of their research partners across universities across Europe, that will help provide some more evidence to show the benefits of using ROBOTTI in comparison with a conventional system in the field. So I will make that available to share with anyone who is interested when that comes about. So you may recognise the shape of ROBOTTI. It is a gantry style system, and this is by no means a new idea. But there were some key limitations to gantries in the past before that made it a challenge for them to work, and they didn't catch on. But by removing the driver and mounting the implement centrally in the middle, not only are we reducing the overall weight of the machine, but we have our weight centered and our working point in the center of the machine, which means that we're not hanging something off the back of a tractor that we then have to compensate with weights on the front, adding more compaction and damaging our soils more than necessary to get the same task done. The working widths of ROBOTTI can be pre-specified when ordering one from the factory. Our smallest one we've currently got working is Home Farm Nacton's. Theirs is working on 72-inch wheel centres, which is 183 centimetres. That's to fit over a single conventional bed that works with their systems. I think it's highly likely we'll be seeing more ROBOTTIs that size in the UK because they will drive straight into an existing system where people are using beds. By turning the wheels around in the same way you do on a conventional tractor with offset wheel pans, you're also able to make that same machine a 2-metre wheel centre machine, which fits into another set of standardised beds. In Europe, though, they're more commonly selling ROBOTTIs to work not in bed systems, but in row crops, for the likes of sugar beet and maize, where they have a wider working width to increase your area covered and your field efficiency. And standard ROBOTTI sizes can go up to 3.65 metres. That may also work in some of our bed systems in the UK because that would actually allow ROBOTTI to straddle 2 beds and work there. ROBOTTI runs off diesel and has a diesel hydraulic system to propel it. There are 2 engines, one in each of the boxes on the sides. The left engine on this side with the screen drives the hydraulic power for the 4-wheel drive, the steering and the link arms. The engine on the other side produces the hydraulic pressure required for the PTO and the external hydraulic spool valves. When we're weeding or hoeing with an implement, we don't require both engines to run because we're not using the PTO or any external hydraulics. Therefore, we can only run with one engine, burning the appropriate amount of diesel for the job and producing the horsepower required for the job. Now, everyone says to me, Tom, this is the future of agriculture, this is robotics. Surely it should be electric, hydrogen powered, have solar panels on it. But the realistic answer to that is ROBOTTI is a product that is for commercial farms, for commercial use. And there's a reason we currently don't have any options for a conventional tractor that's electric. The technology, as far as I can see it, is not at a point yet where we can use it in an efficient, effective manner that we can have comparative running costs and area covered as we can with a diesel system. That said, we are burning far less fuel than a conventional tractor, with an operation such as hoeing, using between 4 and 6 litres of diesel an hour. And in a typical setup, though it does depend on soil type, field size, how often you're turning, we could cover 2 hectares per hour hoeing. When we need the PTO for such operations such as drilling or band spraying or spot spraying, which are also tasks we're ready to perform with ROBOTTI, we then start the second engine and allow that to be used as well. ROBOTTI is a very modular setup, and the hardware is incredibly basic. It is old technology that farmers are familiar with. They can get stuck in with their spanners, repair it, they can service it easily. They do not need specialist tools that may be required with battery technology. And we're seeing a massive positive response to this from UK farmers, but also with its modularity. When the technology becomes available for us to electrify machines or power them in a more environmentally friendly manner, such as using a varying range of energy sources, then it will be a simple swap to change the power units for ROBOTTI, as all of the clever stuff that allows ROBOTTI to work is in its software and is in the setup, is in the route finding, and is in the autonomous systems. Now, I'm going to show you a short presentation that will demonstrate how you would set up a field for ROBOTTI, and it will give you a brief bit of exposure to our online platform and how you use ROBOTTI. So I'm just going to share my screen now. So what you are hopefully now able to see is the ROBOTTI dashboard. I have my 2 units, my demonstration unit and Home Farm Nacton's available there, and I'm able to monitor them in real time anywhere in the world to look at such things as their fuel level, seen in the top left-hand side, their status, their location, what operations they're performing. The little grey circle, second from the right, also demonstrates its status, whether it's working autonomously, it has an issue, it's being driven manually, or it's parked. Or in this case, being grey, they're both turned off when I took the screen capture of this image. What's really exciting for me is every day in my office, I'm seeing Home Farm Nactons with a blue light there, working autonomously in the field, normally for about 14 hours per day. So now we want to set up and create a plan for ROBOTTI to allow ROBOTTI to work in the field. And this is something where we have to train farmers to say, you do not take the machine to the field and do your setup there. The setup is done in the office now. And when you take ROBOTTI to the field, you only have to press start. So next slide, I'm going to show you how we create a plan. So I've selected the create a plan, and then there are 4 different green ticks I need to get to allow ROBOTTI to create a plan. And if you can see on the left-hand side at the top, we have field. That's the first one we need a green tick for. And the bottom left, we have implement, headland size, and rows. These are all the different stages of creating a plan for ROBOTTI. At this point for a field, I would either upload a new field, record one with ROBOTTI, or use one from an existing shapefile that I may have taken from other equipment on the farm, or driven around the field with a quad bike or something like a mapping tablet that I use regularly. For this example I'm going to give you, I'm going to use a field that I've already uploaded. So I next select my field. This one's one on my family's farm at home, a little field with a post in it that's got some good curved edges, so it's a great way to demonstrate the route path. I recorded that by walking around the field with a mapping tablet, and I'm able to see it clearly labelled under farm and then under field. And if you can see in the top left-hand corner, next to fields, we have the green tick. So that means the first part of the operation is confirmed. Then I move on to the implement selection. Now, if I have different ROBOTTIs, I need to specify the implement for them. I'm always using my demonstration unit, which is my autonomous Agri Solutions ROBOTTI. And now I'm actually going to create a new implement. I would only have to do this once for each implement, as my other ones would be saved under camera, seeder, weeder, mower. Those are just files to organize them, and I could have many more lists of different implements that I'd use with ROBOTTI. So I select create a new implement. At this point, I need some raw data to put into it. I need to name it, and I've named this the IAgrE drill. So this is going to be a drill. The type of implement it is, it's a seeder. And now the GPS offset, I need to know what does that mean when it says GPS offset. And we're given very clear diagrams at each step of the way. When you click in that box to put the information in, it shows you a diagram of where you have to measure. So it's very easy for farmers to understand. So I've selected my GPS offset, and now I've selected my working and non-working speeds. So my non-working speed for this is 5 kilometers an hour. That will be when it's traveling around headlands, moving to my start point, performing turns, though it does vary slightly when you're turning as it slows to turn. And then my working speed. And I set that at 4.1k, just because this is a hypothetical implement. Now my working width for this implement is going to be 3 meters wide. And my working distance, which is my next box to fill in, it's given me another diagram to show me how I would measure that to understand what the working distance is. I input that data, and then I need to select my hitch height for the implement. Now, it can be quite hard to picture an implement on your ROBOTTI and understand what the hitch height is. So what I would always advise a farmer does is set their hitch height far too high, higher than necessary, because when they're able to do their first pass in a field, they can manually adjust it using the remote control and fine tune it to exactly the position they want and get the best results from the implement after as little as 20 meters of travel down the row. And then that will be saved and recorded to that implement. So for every operation after that, it continues. If in a different field, in a different situation with different moisture conditions, you need a different working height, you can adjust that again in the same way and it will replace the saving. Here I've also determined that I need my PTO on. It's always going to be on, and what speed it's going to be at. So this is the process that takes slightly more time, but it's a one-time job. After I've done this, I don't need to do it again for that implement. It is always there. So now I've done my implement, the next thing to do, and I've got my green tick for that one, is select how I'm going to work my headlands. Now, because we're primarily focused on the fresh produce industry and bed systems, for some reasons I'll go into a bit more detail later on in my presentation, we often use a turning area because the headlands aren't worked. But this is not by all means essential. You can also set a plan that works the headlands with ROBOTTI as well and have a fixed corner radius or a varying corner radius. Again, those terms don't necessarily mean a lot to people, so we give a clear diagram so farmers can understand. Farmers are very particular about how they do their headlands, so it's good to give them options. The next thing I need to do here is select my start point. So where am I going to drop the ROBOTTI off in the field? And you may be able to see a small green flag in the right-hand corner of the field, and that's where the ROBOTTI will begin its operation from, and I can choose to have the same endpoint or a different endpoint for it. Here I selected an endpoint on the other end of the field as if I was moving on to the next field, though I don't actually use that one for the plan. I'm also inputting the way that I turn and the way that I work the headlands, seen on the left-hand side in the tick boxes. And we're going to use this really exciting feature called the zero turn. The zero turn allows the two front wheels to turn in towards each other, facing inwards together. And then the right-hand side of ROBOTTI can drive forwards, the left-hand side backwards in a similar way to a skid steer, but without stirring up the ground, and able to turn on the spot, which can reduce your headland sizes. And in a bed system of growing, this is really essential because the more growing area you get, the more efficient you can be. Finally, I need to select the way that I perform the mainlands in the fields. I can either use an AB line, fixed rows, or bed systems. The time you will use fixed rows or bed systems is when you've drilled with ROBOTTI or planted with ROBOTTI, and then you want to go and perform another operation following the same systems. So you would actually select your saved bed systems or saved rows. For this one, because it's a new field with a new implement, we're going to use an AB line. I can upload an AB line, select a boundary, and people that use modern tractor guidance systems will be familiar with a lot of this. So we're able to take that off the bed former tractor that's been beforehand and input that into ROBOTTI. But what we're doing here, because we're just drilling a field, is we're going to use the optimal and optimized AB line that it is calculated via ROBOTTI's algorithm to work out which is the most effective way to create an AB line in that field. That's then shown there. I can adjust it or keep it if I'm okay with that. Then I also select, sorry, talking a bit fast. The next part is my driving pattern, and I can progress row by row, which may be essential if we're trying to work in time with irrigation or other tractors in the field. We need to know that we're turning out of one row, going straight into the next one. But when ROBOTTI is working completely alone, you can have an optimized route that doesn't turn row by row. It works in land systems that allow it to perform the field in an optimized manner. I then preview my rows, and at this point I could select or delete one. It doesn't show my headlands currently, though we are working on that, but it does just preview my main working rows. And if there's a small one I'm not happy with, such as the one seen in the bottom here, I would be able to delete it at this point. Now I've got my 4 green ticks on the top left-hand side of the screen, which means I'm ready to go, and I can click to plan this here. A final check to make sure I've filled in all of the correct parameters and I'm happy with everything. And this whole process to this point usually takes me 10 minutes to do this, as long as I have the raw data available. And that will then go into the Danish server system, is uploaded into the cloud, where the route is then created. This one, for this setup kind of field, I produced this morning, and it actually came back to me in about 1.5 minutes, but it always says under 10 minutes, under 15 minutes, under 30 minutes. As the more complex a field, the larger the field, the longer it takes to process this large amount of data and create the route plan. Now I'm waiting for my route plan, and I get a notification. It's blue when it's being created, green when it's finished, and I'm then able to access and view my route plan. So what I do now is my final confirmation to see that I'm happy with the field. And this is a really exciting, clever part about what ROBOTTI can achieve that makes it a standout piece of autonomous machinery, is that it doesn't just perform the rows, it performs the headlands, and you can see the whole route plan and the turning there. Also, we're avoiding the telegraph pole in the middle, which we have predetermined and shown in the plan. So at this point, it's automatically uploaded in ROBOTTI, and anyone now can take ROBOTTI to the field and start this operation. I can look in more detail at some of my parameters, such as my working area, how long this is expected to take, and compare that, so I get more data and understand more about how I'm farming my fields easily before I've even done the task than I may have using a conventional system. I think that's all for this software side of it and the ROBOTTI dashboard. So I touched on the crops we're targeting for ROBOTTI, to use ROBOTTI for before, and I keep coming back to this fresh produce. And it's not only because I've grown up on a farm that grows fruit and vegetables, but it's because there are a lot of challenges throughout agriculture at the moment, and some of the biggest challenges are actually affecting the fresh produce industry. I'm sure you're all aware of the challenges in sourcing labour and migrant work to come and perform tasks in the field. We're also having pressure put on farmers to reduce the amount of chemicals we use, whether it's social pressure or actually legislative pressure. That means we can't use chemicals. And farmers are really focusing now on how they can continue growing these high value crops that need high inputs in an effective manner, where they can still provide the cheap food that we all appreciate in our supermarkets. That is why these customers are prepared to move forwards with automation. So in no way am I saying that ROBOTTI would not work for someone growing maize or sugar beet or potatoes. We can also plant potatoes with ROBOTTI. We can do broadacre crops, we can do combinables. I just don't believe that these customers are going to be the early adopters of ROBOTTI and the first people to use it in the UK fields. That's why we are primarily focused on introducing ROBOTTI to the fresh produce industry to allow them to display ROBOTTI to the rest of UK agriculture, so that we can see the benefits, prove it in this type of farming where there's a here and now need and desire to use this automation, continue farming the way we want to be and the way we're going to have to be in the future. But then also when these challenges become more appropriate and become more difficult to deal with for a broad acre crop and a combinable crop in your cereals, then I will be in a position where I'll be ready to take ROBOTTI to those kind of customers. Now, I've said a lot and I still have many notes to go through, but I think I've covered nearly all of the points that I want to say, the really important ones anyway, and I think I'd prefer to take your questions now.
Thank you, Tom. That was brilliant. Really, really interesting stuff. I've got a question from Mr. Whiting. Michael, do you want to unmute?
Good afternoon, Thomas. Thanks very much for the presentation. Was there an article in Profi on the unit? Was it one of the recent editions of Profi?
It could well have been. I've nearly lost track of our media exposure. We've been really successful and put a lot of work into that. We've been in nearly all of the different agricultural medias out there now.
So obviously it's a European developed system. So where are the Europeans up to in utilising this system and making best use of it and improving their farming profitability?
So there are about 30 ROBOTTIs across Europe being used and one in the UK being used commercially. They're being used in a range of different systems. Some of them are being used by universities and research institutes because they benefit massively from the accuracy and repeatability that ROBOTTI provides by farming with it. There are also contractors using ROBOTTI in the Czech Republic, and they've actually been, they planted a crop of maize for 3 weeks straight with 2 ROBOTTIs, only turning them off for fuel and filling up the seeds. They were running them 24 hours a day. So it is being taken on more and more by farmers across Europe, but actually AgroIntelli's key focus now, due to some of the hard work I've put in, is the UK, because we're having bigger challenges, especially with labour, and there's more demand from our companies to have ownership of ROBOTTI and not just use it as a service, but own one for themselves. And that's why we're focused on driving forward for the remainder of this year and 2022 to see the most commercial units across Europe in the UK.
Thanks very much.
Tom, if I'd like to ask a question, if I may. Could you talk a little bit about the safety aspects?
Yes, I've got
the machine running on its own. Yeah.
So I've got that on my notes, circled with an exclamation mark next to it. So that's something I definitely did mean to talk about, but I've just missed out. So there are 4 levels of safety with ROBOTTI. We begin with our geofence. Now, a geofence was the green line seen when we're mapping the field boundary. And what that geofence means is that the robot will not run autonomously within half a metre of it or outside of it. So if for any reason ROBOTTI lost its route in the plan, it would stop to function when it reached that geofence. Also, I've just brought up another part of the safety, which is ROBOTTI cannot function without everything working perfectly and having the correct connection needed. We use an N-trip connection, which is far more robust than a radio connection. So when we're next to trees, next to buildings, in difficult fields that are on slopes and in valleys, we struggle to lose connection. I've tried really hard to make ROBOTTI fail from that point of view, so I know its limits, and I'm struggling to make it fail from a connection point of view. So those are some of the beginning safety features. The next is a LiDAR scanner at the front of ROBOTTI. Now that is currently scanning the total working width of ROBOTTI in front of it, and if any obstacle moves in front of it, it will begin to slow down gradually and then stop just before it approaches this. And this is something I demonstrate at every demonstration I'm at. I will stand in front of it, a member of the audience will stand in front of it. We even had someone drive their Range Rover in front of it and surprised me the other day. But I was very glad it stopped then. But it always does, which is the point. If that, for whatever reason, fails, there is a fail-safe of a red bump stop bumper around the whole front of ROBOTTI that senses any impact and will stop. If we're in a situation where we forgot to predefine a telegraph pole and we haven't mapped that in the field, ROBOTTI will approach it, sense it, stop, and then it will send you a text to say, there's an obstacle here that I don't know about. Please, can you come and tell me what to do? Whereas if I walk in front of it, it will stop. And then if I move away quite quickly, it will then start again and continue on with the progress in the field. Final level of safety is that from our online platform and from our remote control, which I have here, we have an emergency stop button that we're able to shut down the robot from. We have cameras we can view through the robot live, pointing forwards and backwards, that we can also access. ROBOTTI meets all appropriate ISO standards that are available currently and is CE marked, so we believe it's safe enough. Though we are working with Harper Adams' hands-free farm team, we've just began talking to them, so hopefully we can provide them with some real-world data of how farmers are commercially using autonomous machines to create a code of practice for the use of autonomous machines with the brilliant stuff they're doing at Hands-Free Farm and their experience there, so that we can preemptively legislate or help the government get to a position that when they have to legislate for autonomous vehicles working in an agricultural environment, we're ready for it. But as with everything, the technology is always ready before the legislation is.
Thanks, Tom. Brilliant. Alan, does that answer your question as well, or is there some other points you want to raise?
No, thank you. You anticipated me, Charlie. You know me too well. And well done, Tom, for anticipating it. I would always pick up on something with my own health and safety background. It was particularly the development of a standard and working with others. And I know it was probably 18 months ago, I think there was a meeting up at Harper with HSE people involved as well. And it was really, that was where I was coming from. So, you know, as far as UK and what's happening elsewhere in Europe in terms of developing that common standard is vital. Thank you.
Okay, a question on LiDAR.
Yeah, can you hear me?
Yes.
Hi, it's William. Sorry about the me. I just wondered because on the on-highway side of things, there seems to be quite a big roadblock with LiDAR when you've got perception algorithms running, especially in fog, because the LiDAR today is probably, the wavelength is very close to the sort of particle size of fog particles, and you get a lot of backscatter and inaccuracies on range. I just wonder if you'd come across any problems if you've got a lot of fog, if you're running in fog. Obviously, perception algorithm is probably quite important to know for range accuracy. Or have you got a radar as another sensor, perhaps looking at perception?
We're not experiencing a lot of problems with LiDAR. Even on rainy days, we're okay. Dust on the LiDAR scanner front could cause an issue, but we do set that as regular maintenance when you take ROBOTTI to the field, that you wipe it and clean it. The system is fail safe, so if there's any conflict or something not working right there, the machine will not run, as opposed to it working without the LiDAR working properly. But to be honest, that level of detail that you mentioned is information I could get to you from the Agri and Tele development team, but it's not something I've been involved in at my level.
Okay, I guess I don't know if does the machine ever reverse. I mean, I guess you don't need 360. No. You don't need 360-degree perception. It's just probably
no. We're only looking
or 90-degree field of view, maybe.
Yes, we're only looking forwards. We don't reverse in any form autonomously. There is a way that can be unlocked for particular university needs that may require some testing there. But from a commercial point of view, for any farmer using ROBOTTI, there is no way it can autonomously reverse. And also for the LiDAR scanner, we're currently not doing any obstacle identification, but that is something being looked into as well for different ways of dealing with things, because being in an agricultural environment, we are dealing with standing crop. It isn't a problem for ROBOTTI yet, but if we become more restricted on our sensing height and the level of sensory demand that we need as a standard, then that's something we would probably have to look into to mitigate the chances of someone being laid down in a standing crop, for example.
So another quick one. You mentioned standardization, and I saw that at the Harper Adams there was a conference recently. There's a lot of standardization on highway. I think ISO 26262 I think is one of them, and the other one is SOTIF, which is basically if you get situations like a paper bag flies across a car, what's it going to do? You know, anything like that that's out of the ordinary. Do you think the agricultural side of things is actually looking at the on-highway stuff that's been done already, because there's a lot of work being done on highway and I guess sensors as well, because there's a lot of investment in the technology. I guess that's just going to implant itself in Agri, I guess.
So yes, from that point of view, I know as an industry as a whole, with automating agricultural machinery, I focus a lot of my time on researching what other parties are doing within the industry, how they're overcoming these problems, and their solutions as well, to be able to provide feedback to Agritechnica for their product development. They're also very good at it themselves. Yes, there is definitely a look at what's happening on highway, though there are a lot of key differences there. We have a defined route that we stick to, whereas working on highway, you're having a dynamic adapted route that you plan as you go, if that makes sense. You're not following just a GPS signal. In theory, ROBOTTI is blind. It does not decide where it goes. It is told where to go, and it just senses in that path in front of it. But hopefully, with more developments across the industry and a bit of kind of communication between us all, we'll be able to overcome these challenges as they're presented. But it's definitely our most important thing is we have to stay safe doing this. We have to have it working right. And I sometimes do get a little bit concerned seeing some of the machinery that's coming out of America from an autonomous point of view, because though they're in an environment where they don't have to be very safe because they are in the middle of nowhere in massive fields where someone isn't going to walk across it, I think we need to be careful that we understand that the situation is different here in the UK and across Europe, and we have to make sure that the obstacle avoidance sensing is always the highest priority and the best it can possibly be while still working effectively.
Yeah, I quite agree. I think it's I think there's more chance of seeing level 4, level 5 autonomy in a field than you're going to see on our public highway.
Okay, Francis Ward, there's a question.
Yeah, hi Tom. Thanks for a very interesting presentation. Bear in mind, my question comes from a position of almost total ignorance on this stuff, but what I'm just asking is whether there is a risk of vulnerability to cyber attack, and if in the longer term we are heavily dependent on such systems, whether there is therefore a knock-on implication for national food security from this kind of technology.
I was asked the same question last week, and until that point, it was something I had not considered at all. Being from an agricultural background, I've never really thought about cyber attacks much. They haven't come into any of my line of work, but actually, it is a risk, and there is an element of risk there, because we are relying on a network connection. We are having a machine that can be remotely controlled and autonomously controlled. To be honest, we have bigger challenges. We have more likely difficulties to overcome that we're focusing on. We're using for our data processing third-party company systems that have security in place, such as some Amazon data processing systems that again, this is a level I'm not very involved in much detail. This is more at the development side from Agritechnica's side of it, and as the UK dealer, I provide a lot of farm feedback, but I don't really get inside with the product development at that level so much. So it's something that will have to be considered, but I don't think it's a here and now problem. I think we have bigger challenges, mostly about making it work effectively, proving how it works, that we need to focus on to get this out there. I only think when there are many machines out there and people know what they are, will it then be potentially vulnerable to any sort of cyber attacks.
Sure, thank you.
I think it does raise a question I've thought about for a while. Really, is not so much cyber attack, but vandalism, and obviously it's an unmanned machine in a field, and you get people roaming around the countryside doing things they shouldn't be doing, and it wouldn't be the first time machines get vandalised, windows get smashed, and people interfering with equipment. But yeah.
From that point of view there with vandalism, that's something when insuring these machines, we had to clearly work out how we're going to do that. It was a bespoke insurance package to say, well, what's it doing? How's it working? There isn't a standard in place like insuring a tractor. It's actually very attractive to insure from insurance companies' point of view. The hardware elements here are simple and actually less expensive than a lot of modern tractors. We are still vulnerable to vandalism, to battery theft, to diesel theft in the same way any agricultural machine that could be left out in the field would be. But when it's working autonomously, if someone were to approach ROBOTTI, it would then stop and you'd be notified that it had stopped. That would also give you the opportunity to turn the cameras on and look through them, and then you're in a better position than maybe another piece of agricultural machinery left from recording the people doing the damage and what there is. It also doesn't necessarily look like a tractor. So people that are coming to steal something from it that they think they can resell, they don't know what it is and they don't know how to sell it. That will, again, be more and more of a problem as we develop in the future and we have more units in the UK. But in the here and now, we're quite confident that it can work in an effective manner in the fields fully autonomously.
Yeah, thank you for that. Richard Robinson.
Thank you first of all for most excellent presentation from the field, which is really good. My original question was how much did it cost, and added to that, given that I've spent some time talking to Alan before we started your presentation, one of the tricky bits we had with something that we were doing, which was also autonomous, was hitching up when you were changing implements. So there's two questions for you.
Okay, firstly, cost. So it's very difficult to price ROBOTTI because the research and development has been going on for many, many years, and that obviously has a substantial cost to it. And it doesn't do what a normal tractor does. It has key limits. It can't drive on the road. It can't go grain carting. But what it can do very well in a more cost-effective manner. So I think the price point's really appropriate, and I will get to the big number in a second. But actually, it's the least concern we're having from farmers that are seriously interested. They're not concerned about the price, and it has been set at £150,000 sterling for the UK at the moment, though that does depend on the exact specification of ROBOTTI that you order. And that's been based off a tractor of comparable horsepower, though it is hard to find a comparable tractor because this is a unique machine. There isn't anything quite like it.
Yeah, that makes sense, to be fair.
It's actually much easier than an ordinary tractor than ROBOTTI. I've pinched my finger on pins 100 times, hitching up normal implements, had to kick the legs into position, had to get on and off the tractor about 10 times. Maybe that says something about my driving. Maybe it says something about the way we have to hitch up implements. With ROBOTTI, I can stand incredibly close and drive it forward and back, left and right, incredibly slowly, and lift the link arms, and I can hitch on with ROBOTTI far quicker, safer and easier than I would ever be able to with a tractor. We're not looking at automating that at the minute. There isn't a need for it. The cost implications, the challenges there. I actually did a project studying at Harper Adams about autonomous hitching, and I see no need for it to be implemented yet on agricultural machinery.
No, it's very good. Thank you. We, as you'll probably know, we were involved back in the day with the turf trooper that was in the hall at Harper, which was one of our earlier attempts. And presumably you know about the Murtry brothers who were heavily into autonomous mowers.
Yes.
Okay, we've probably got time for one more question. I do apologise to Kalishi. I missed your question. It shot past on my screen, but do you want to unmute and ask?
Yeah, thank you very much. A short one. Sorry. So I was going to ask, how does the farmer visually monitor weeding efficiency? For imagine working on more than 5 hectares of farm. How would you know actually the robot is actually removing the weeds? Or for curiosity's sake, the robot is actually removing the weeds. So I would think that should be a camera on the robot that records the worked area so that the farmer can view it from the office. Is it the case?
That is correct, yes. There are both forward and rear facing cameras that are very high resolution that allow you to see exactly how the task is being performed. The challenge there to overcome is sometimes the data stream required to transfer that amount of data. I'm sure we've all experienced with our Zoom calls sometimes people dropping in and out and blurry images. That's equally the case with ROBOTTI. We always focus on getting the positioning and the guidance right, but we're working on making a more robust system where we can still have very high resolution images both forwards and backwards, but we can see them all of the time.
Okay, well, I think we better draw it to a close now because we're just nearing 1 o'clock. So, well, thank you, Tom, for giving us an excellent presentation and taking time out to do that for us today. Really appreciate it. I think it's superb that we've done it in field as well with you there with the robot. I'm sure everybody's found it extremely interesting. It's certainly a subject that prompts a lot of debate and discussion about the future and where we're going with some of this stuff. And it's really exciting for anybody to be involved with it at the moment. So before we close, I'd like to thank you all for joining us today and hope you'll join us for our next lecture on the 17th of August, where we'll be joined by Alistair Taylor, who's going to talk about agricultural engineering in Africa. So all that's left to say is thanks again for everybody for joining. Thanks to Tom, and see you all next time. Bye-bye.